Deep in the ocean lies a swirling vortex of trash, massive, constant, and nearly invisible from space. It traps millions of tons of plastic every year, harming marine life and polluting our planet silently. What is this mysterious gyre and why is it growing? Don't forget to like this video, subscribe for more eye-opening content, and stick around as we uncover the ocean's plastic trap. 1. What is an ocean vortex? An ocean vortex is a massive rotating current system formed by Earth's wind and water forces. These spinning gyres circulate thousands of miles and trap floating debris in their rotation. The North Pacific subtropical gyre is the largest and best-known vortex holding plastic today. Vortexes are not whirlpools, but slow-moving spirals that gather materials for long durations. They act as magnets for waste drifting from coastlines, rivers, and maritime shipping routes. 5 major ocean gyres exist globally, each playing a role in plastic accumulation patterns. Once debris enters a vortex, it may stay there for decades, continuously breaking down. 2. Why plastic accumulates in vortexes. Plastics are buoyant and durable, making them perfect candidates for long-term ocean travel. They resist decay and remain afloat for years, circulating across global water systems. Vortexes pull in plastic from thousands of miles away, including urban coastlines and rivers. Once inside, there is no natural mechanism to push the waste back out or send it to shore. The calm waters at the vortex center slow down movement, trapping items in a gentle spin. Sunlight breaks plastic into smaller pieces, but does not remove it from the vortex system. Microplastics accumulate in massive volumes, making up much of the vortex's plastic weight. 3. The Great Pacific Garbage Patch. The most famous plastic vortex is the Great Pacific Garbage Patch between Hawaii and California. It lies within the North Pacific Gyre and contains over 1.8 trillion plastic pieces. Despite its name, it is not a solid island but a scattered mass of plastic particles and debris. Macroplastics like nets, bottles, and crates float among trillions of tiny microplastic bits. The patch is estimated to weigh over 80,000 metric tons, and it is still growing fast. Winds and currents draw in plastics from Asia, North America, and as far as South America. Some items found there are decades old, preserved by the ocean's low decomposition rates. 4. The other 4 ocean gyres. Beyond the Pacific, there are 4 other major vortexes with similar plastic buildup problems. The North Atlantic Gyre hosts a large garbage patch between the United States and Europe. The South Pacific, South Atlantic, and Indian Ocean gyres each hold less-known patches. These systems spin slowly, pulling in regional debris from surrounding countries and rivers. Though smaller than the Pacific patch, they pose significant threats to local marine life. The South Atlantic gyre traps waste off Africa's coast, while the Indian Ocean collects Asian trash. Each gyre is affected by shipping lanes, storm debris, and poor coastal waste management. 5. Impact on marine life. Animals living near or in vortexes often mistake plastic for food or become entangled in it. Seabirds ingest bottle caps, straws, and other fragments, often dying from internal blockages. Turtles consume floating bags that resemble jellyfish, leading to starvation and slow death. Fish consume microplastics, which then enter the food chain and eventually reach humans. Larger marine mammals get caught in ghost nets, leading to drowning or restricted movement. Ingestion causes internal wounds, toxicity buildup, and reproductive issues in many species. Plastics often carry toxic chemicals that leach into tissues, affecting hormone levels and growth. 6. Why cleanup is so hard. Vortexes cover millions of square kilometers and move constantly with changing ocean currents. Plastics are scattered across depths and sizes, making targeted cleanup difficult and expensive. Removing waste without harming marine organisms like plankton is nearly impossible today. Weather conditions, fuel costs, and ocean logistics limit how much can be collected safely. New debris arrives faster than we can remove existing waste from these massive gyre areas. Ships must travel thousands of miles, haul tons of trash, and sort it before disposal on land. There is no centralized authority or country responsible for gyres in international waters. 7. Where the plastic comes from. Most plastic in vortexes originates from land-urban runoff, littering, and poor waste systems. Rivers like the Ganges and Yangtze transport millions of tons of plastic to the sea yearly. Unregulated dumping, tourism, and industrial waste add to the growing ocean-bound plastic flow. Fishing industries lose nets and gear that become long-lasting floating hazards in gyres. Developing nations with inadequate disposal systems unintentionally supply tons of debris. Storms and floods wash trash from landfills and streets directly into the ocean system. Ships also lose containers during storms, adding sudden bulk plastic into vortex circulation. 8. Plastic's long lifespan at sea. Plastic in the ocean does not biodegrade like natural materials. It breaks down very slowly. A single bottle may float for over 400 years before it fully disintegrates naturally. Wave motion, sun, and saltwater fragment it, but do not remove it from the ecosystem. These fragments become microplastics that are consumed by sea life or stay suspended. Plastic's resistance to decay means every piece ever produced still exists in some form today. Nets and fishing lines can entangle marine life for decades without degrading or breaking. Even biodegradable plastic often fails to degrade in cold, low-oxygen ocean conditions. 9. Solutions and strategies. Ocean cleanup technologies must expand, using autonomous vessels and advanced filtration tools. Interception in rivers and coastal cities must be strengthened to block ocean-bound plastic early. Global treaties should enforce limits on single-use plastics and dumping in all maritime areas. Brands must be held accountable for plastic packaging through extended producer responsibility laws. Incentives for biodegradable materials and zero-waste product design must become industry norms. Education campaigns can shift public behavior and raise awareness of long-term plastic effects. Recycling must be reformed clean, efficient, and actually reused in meaningful economic cycles. 10. What the future holds. If nothing changes, vortexes like the Pacific Garbage Patch will continue to grow rapidly. By 2050, there could be more plastic than fish in the ocean by weight, according to estimates. Entire ocean zones may become uninhabitable for marine life due to chemical and plastic buildup. Coral reefs, breeding grounds, and migration routes could collapse under pollution pressure. Fisheries would suffer economic losses as species dwindle or become unsafe for human consumption. Tourism may decline in once pristine areas affected by visible plastic trash and dead zones. Climate change and plastic pollution will combine to stress ecosystems beyond natural recovery. But if global action is taken now, vortex growth can slow and cleanup can gain ground. We may never erase the plastic entirely, but we can stop the flood and heal what remains. The ocean's resilience depends on our willingness to confront the plastic problem together. The ocean vortex isn't just a patch of floating bottles, it's a symbol of our throwaway culture. Understanding it is the first step to fixing it. With awareness, innovation, and action, we can reduce what enters our seas. Don't forget to like this video, subscribe for more powerful insights, and share it to raise awareness about the true scale of plastic pollution. Let's protect our oceans together.